Okay, so in this program, we're going to learn how to create a loop in our program. More specifically, this one is going to be looking at the while loop. So what I have in front of us right now is a program for our dragster project, which we just completed. So my pseudocode says wait until a switch is pressed, then I'm going to start the left and the right motor at full power, and then I'm going to wait enough time for the dragster to cross the finish line. I now have my program code written here. Wait 10 seconds. I've got my comments describing what's going on. You see here that I have my right motor at negative 127, negative full speed, so it's actually going in reverse. And that was because of the fact that my motor, the way that my motors were mounted, in order to get the wheels turning in the same direction. Some of you might not have had to do that depending on how you mounted your how you mounted your wheels in your dragster. So anyway, when I run this program, what's going to happen is when I press this button, the two motors are going to start. After 10 seconds, it reaches the end of the program and it just like terminates because it's at the end of the program, so it stops. Problem with this is now that my program's like run through, the only way to get it to run again is I'm actually going to have to go back to the computer. I'm going to have to hit, the start button again on my computer to get it to start again on the Cortex, which isn't really ideal for testing, and it's not really going to help us when we have a program that we want to be repeatable, that keeps going around and allows us to basically run forever or until certain criteria is met. So what I'm going to end up doing is creating what's called a while loop. Okay, and if I go over into, let's see where it is. It's actually under C constructs, and I'm going to go into my control structures. Okay, this is where I'll find the while loop beginning, and I'm going to go ahead and put that in. Okay, what this loop ends up having is it comes with a condition. This is what it checks for. When this condition is met, it then enters the body of our loop. Okay, so I want this code right here that I have for my dragster to actually be inside of my loop. So I'm going to cut this out and I'm going to go ahead and put it inside the body of my while loop. And you can see that the while has its own curly brackets. The code that goes inside of these curly brackets, I'm actually going to want to indent so that it lines up inside of the curly brackets, making it easier to read. This way, if I have any code that's written outside of the while loop over here within that's inside of task main but not inside the while loop, I can more easily see it. So now let's go ahead and create a condition for this loop. The condition I'm going to create is one that's always going to be true, so that this program is going to end up running forever. Okay, so I'm going to put in 1 equals 1. What this ends up doing is it is checking as the condition. It wants to see if 1 is equal to 1. However, when you're creating it in the program, the way to check to see if this number is equivalent to the second number, you actually need to do equals equals. All right. You'll learn later on why you don't just do a single equals, but 1 equals 1 checks to see if this value is the same as this value. Okay, so 1 is always going to be equal to 1, and so that's always true, meaning it's always going to be running inside of this while loop. It's always going to be inside of here. It's never even going to go outside into this area outside of the while loop curly brackets. All right, now a problem with my program right now. If I were to run this right now, it would wait 10 seconds and then it would come back around up until the until touch. Problem is my motors were started and I never stopped them. So these motors would basically be running forever right now. So I need to add a couple more lines of code. So I'm going to go ahead and after 10 seconds I want to stop my motor, my left motor, and also stop my right motor. That's why it's pretty good practice that instead of allowing the program to terminate be what stops your motors, you go ahead and just put in those stop motor commands at the end of your program, even if the program is going to be terminated. So now what's going to happen is I'm going to wait until the button is pressed, then I'm going to start my left motor, start my right motor. This will happen at the same time. So then I'm going to wait for 10 seconds. After that, it will stop the two motors. Okay. Once it runs this last line of code, it's going to go and it's going to check the condition once more in my while loop. Well, 1 is still equal to 1, obviously, so it's going to go and it's going to loop back to the first line of my code. And it's going to wait until this bump switch is pressed. When that happens, it's going to read through, it's going to come back around, it's going to check this condition again. Anytime this condition is true, it's going to just keep looping around, looping around, looping around. Okay, so this would be a while loop. Sometimes you would create conditions that are not always going to be true. That way it would be within the loop while it's true, but then when it's not true, it would come back outside of the loop and it may run some different types of code. So this will help you with the bonus section of the spinning sign.